Okay, class, let me start off with this because there's something I want to mention. In this tutorial, in this theorem, right? There's a mention about boundedness, no? Yu Tong from the other class, she pointed out that do we really need boundedness, no? Do we really need boundedness? Could we have a case where it is like that? Technically, yes, technically yes. But if you have an interval that's like this, right, then you have a little bit of problem, no? You can't really say about FA and F infinity, see? You can't. Anyway, so for the reason, this theorem actually included the term boundedness in the statement of IBT. If you look into other textbooks, they don't have this phrase in the definition for IBT. They just say closed interval like that, and that is already by default a bounded interval. Or for the reason that you can then say a value FA and then the FB. Otherwise, you're going to run the issue. Right. So boundedness, technically, if you look about it, you can try to draw all different curves where it's not bounded interval, right? It still works actually, no? It still works. Okay. That is actually the IVT. In the case of the EVT, I want to assure you that in the case of EVT, the boundedness is more explicit. No, the need for boundedness is more explicit because in the case of EVT, if your interval is not bounded, say like that, like that. If you have a graph that's like this, like this. If your interval is not bounded, say like that. Say for example your graph is like this, right? Like this, for example. If your graph is not bounded, right? So interval is not bounded, right? Then you might not have any absolute maximum. So in the case of EVT, the boundedness is really needed, in that sense, really needed. Because geometrically, you're going to run the problem if your interval is not bounded. Okay. Oops. Okay, so let's move on to example 32. In example 32, we have done the first part, have we? 33 rather, 33. Have we done the first part of 33? We are done, right? So we have proven that that it has both absolute maximum and absolute minimum by simply proving that this function is continuous on the closed interval from -2 to 2. We now want to do the next important thing, and that is to find the absolute maximum and absolute minimum of the function f. In the case of AP exam, right, for such a thing, right, for such a question, the AP exam actually requires you to do thing, no? To find the value of the function, values of f at endpoints, and the values of f at critical point. So explicitly for such a question, right, you are required to actually show explicitly the value of the function at these two locations. First the endpoints, and then later on the critical points. And potentially, you could even present your solution as a table like this. Okay. So about the endpoints, right? What are the two endpoints that you have? Okay, so you calculate the function value at -2. Now, instead of writing down the answer immediately, I prefer that you look at the function and tell me that for -2, you can use the function -2 plus 2 squared equals 0. I prefer you show it explicitly, which means you therefore know that -2 is 0. Okay. Then you want to find the other endpoints. The endpoint is 2 minus 2 squared equals 0. So now you're settled with the endpoints. Okay. Then the next thing is you want to find the values of the function. values of f at the critical points. And we recall the definition of critical points. Critical point, firstly, right, they must be interior points, and secondly, either the gradient is undefined or is zero. So for our case, right, in this case, this function, right, this function, piecewise function is defined differently over different two different intervals. You might want to draw a rough sketch to see how it looks like. If you draw a rough sketch of this, it looks like that. And this is actually 4. So judging from this diagram, right, you would suspect that at the point x equals 0, the function has a critical point. And how do you actually make the conclusion explicitly? You say that f has a critical point at x equals 0 because, okay, how do you say that it is a critical point? Because in this case, right, is undefined. Okay, then you're challenged now. How do you know it is undefined? To show that the function at x equals 0 does not have a defined gradient, right? You actually have to go and show that, show this, no? You actually have to start off with this line by saying that f prime 0, by definition, technically, you have to show through the calculation that the limit of this, the blue color, does not exist. However, we will leave this kind of calculation to the next chapter. But if you want to give a reason why, since it is okay. What is a cusp? A cusp is actually a sharp corner. This kind of diagram is a cusp. It's a sharp turning. So when it is a sharp turning like this, a sharp corner, you know for sure that the gradient is actually undefined, and therefore the function f has a critical point at x equals 0. Then you want to calculate the value of the function at 0, and then in this case, right, 0, right? 0, which one do you use? 0 use x minus 2. Which means you now can fill in the table when this is 0, this is 4. Then you're gonna ask now, are there any other critical points? To answer the question, it means you have to differentiate the function and equate the gradient to 0 and see if there are x values. If you do it for this question, you will find that actually it's going to get 0 gradient at minus 2 and 2. But these are endpoints, see? So as I told you, so endpoints are not critical points, so cannot. So therefore, you have no more critical points apart from the one at x equals 0. Then you say, from the values of f at n points and at critical points, then you say the absolute max equals to 4 and absolute mean is equals to 0. Right. Some people may take a different view, no? Some people will say, I can do this thing differently by showing that the graph actually increases from -2 to 0, and then the graph decreases from 0 to 2. If you are those who do it this way, you can also determine that it has absolute maximum at 0 in that manner, because you show that from -2 to 0 the grade is positive, and from 0 to 2 the grade is negative. That means it increases all the way up to 0, and then after 0 it comes down again. So that also can establish the fact that the function has an absolute maximum at x equals 0, also can, right? By and large, AP exam requires you to do like that. Just two things at the endpoints and the critical point. In fact, if you look at the later on, you see the solution key provided by AP examination board. You find that they even draw, they oftentimes draw a table like this. Okay, right. Then there's a remark. Okay. There's a remark about asking for the points rather than the value. If you're asking for the point, you're supposed to write down the coordinates. Okay. If it's an open interval, right, do you think that this theorem will hold? So you draw a simple diagram to illustrate that this may not hold if your function is like that. For example, if it's like that, for example, right, right? Okay. So yes, absolute minimum, but not the maximum. Or you can even draw a diagram that's like that. This one, draw like this, for example. This is another illustration that you have something that doesn't work. Why doesn't it work? The absolute maximum and absolute minimum are not defined, so don't have. Okay, so this is an example you can draw to show. Right. Another question people ask is like this: no, you see in the EVT it says must be continuous on a closed interval. That guarantees you absolute maximum, absolute minimum. Supposedly you don't have the conditions of EVT. Supposedly you do not have a condition of EVT like that. For example, your continuity is on a open interval. Can you still have absolute maximum and minimum? And the answer is of course yes, you know. The continuity on a closed interval dictated by the EVT is actually a sufficient condition. Which means if you satisfy the condition, EVT guarantees you. But it is not a necessary condition, which means even if I don't have that condition, it is still possible for me to have absolute min and max. It's something that we're sure. Okay. Then okay. So there's a remark here about function not continuous. Function that's not continuous on a closed interval, like potentially it can still have absolute max and minimum. Just that you go put in more effort to try to locate the absolute max and min. For me, if it's not a continuous function, I probably draw a sketch of graph to see what is it like first. So I can actually narrow down to the absolute max and minimum for such a function. So with this, we're coming to the QCE. Okay, let's invite people to answer. Okay, let's have the first person. Mahil. Number one, what are the three conditions?
Fx exists, the limit of fx exists.
This one must be well defined. What's the next one?
Limit of fx also exists.
Limit as x approaches c must exist.
And both of them must be equal to each other.
Right. Right. The fc must be equal to the limit. Okay, number two, Wen Kai. how should you take us through? F of 2, G of 2, so G of 2. Because both functions are continuous, right? And therefore the individual limits exist. And because the individual limit exists, Wen Kai, right? And because f of 2 is 1, this is going to be f of 2, and this is going to be 4 of plus 4 of G2, and therefore G2 is equals to 3, and this one is equals to G2 and is equals to 3. And then for number 3, this tells you if it equals to the limit of the numerator divided by the limit of the denominator. And this gives you minus 2 over 5. Right, that's number 3. Okay. Okay, Euler for number 4.
You factorize the bottom and then you find that
Right.
if you have x is 1 or 4, then the bottom will be 0.
Okay, that is not what I will ask you, but since you say it, okay, so Euler says there are 2 points where the function is discontinuous. I would like Euler to tell us what kind of discontinuity do you think it is at x equals to 1? The question that I asked for, but let me ask you, what kind of discontinuity do you have at x equals 1 and at x equals 4? And to do this, right, you want to conduct a check, You want to conduct a check on the function as x goes towards 1 and as x goes towards 4. Okay, if you check when x goes towards 1, right, Kenneth, what do you think it will be equals to? What do you think it will be equals to if x goes towards 1?
F goes towards 1, if I'm not mistaken, this question, but
It's either plus or minus infinity.
this one is
Like you find that it's the case.
It's going from plus or minus.
It's either plus or
No, negative
one side.
infinity, negative infinity.
It could be one side positive, one side negative, or both sides positive or both sides negative. It's around there. It must be this thing, okay?
Positive infinity, because it end up in x plus 4 over x minus 1, and
Okay.
since whichever direction you end up in positive.
Okay, so according to Kenneth, it's going to be infinity now. Okay, I'm just putting as either positive or negative, okay? Then when x goes towards 4, when x goes to 4, right? It's going to be 8 over 3. Is it? I think it's 8 over 3. I think it's 8 over 3. Let me know if I got it wrong. In any case, what I'm trying to tell you is, when x approaches 4, right, it's actually a finite value. And because it is a finite value, right, that tells you that the discontinuity at x equals 4 is right, removable. Okay, then we have another number 5. Okay, Katit, you want to try number 5? Where are the intervals for which you will find roots?
A, C, and D.
Right, A, C, and D. Why is that so? Because at minus 2, it is positive. At minus 1, it is negative. There's a change of sign. Therefore, you are guaranteed of roots. Could be more than 1, Right, could be more than 1. And that brings us to the end of this chapter. For those who have tried, right, they told me number 1A is doable. They can do it. Yeah, no issues. You just have put x equals to 1 into it. They say number 2 and number 3.
Number 2, number 3.
Sorry, 1 A, B, C.
Uh-huh.
A show of hands on those have tried.
Wait, that's supposed to be hard.
No, it's just a warm up.
Yeah.
Okay, good. For number 2, let's hear from the floor. I cannot remember your name. Ryan. Ken. I have a slight cough, no? That's why I mask up. No? I will see a doctor later. I tested this morning before I went off. Because I'm also worried. My daughter is, I still need to go to school, so I tested in the morning to make sure I'm alright. No? It's negative, at least for the morning, but I will go to the doctor today. After lessons, I'll go. The boy, Okay. Tell us your method.
You factorize
Right, just factorize. Let's hear from who's behind Zoe? Haruhi, right? What happened to her? Wow. Okay, Zoe. 2B, have you tried? Okay, how do you do 2B? Right, just factorization. And then for C also, you just tidy things up, it will work like it. So 2ABC is like a giveaway, and I'm sure 504 does not mean to go through 2ABC. No, you find it, you can manage it. Right. How about 3A? Let's hear from something, right? Jingwen. Okay. Okay, how could I have forgotten Jingwen? Okay. Jingwen, it looks like a name that people, I've heard of the name Jingwen before, no? Yeah, a lot of people give Jingwen, and a lot of people give their daughters the name Chloe, There's Chloe all over the world. Okay, Jingwen, Jingwen 3A, how do you do 3A? Brilliant, right. Right, multiply by conjugate, you just tidy out the arithmetic, it will work, okay? How about 3B, Jingwen? Right, and for 3C, what do you do, Jing? What do you do for 3C? Alternatively, we could have done 3C by factorization, Yeah. Right, you can do it by factorization. Okay, this is an alternative way. Alright, so I think now number 1, 2, and 3, I am sure 504 will be able to manage this now. Okay, for number 4, I'm not thinking that you can't do, no. I'm worried that you don't do it and present it the way we need. I want to caution you, if you don't present the way we need, it may get 0, no, even though you might get an answer. So for question 4, it must first and foremost establish that this is the case. It must say explicitly must say this as explicitly, then this is minus x squared So the first thing you do is to establish the inequality. Then secondly, you must actually work out the limit, limit of the function on the left. Show that it is 0, and then say that the limit of the function on the right is also 0. Therefore, by st. Okay, you should spell again, spell in full the limit of this one. In the other class, someone pointed out, that actually instead of ln of modulus x, right, it could have been anything, Someone in the other class say that, in this question, right, they use ln modulus x. They say actually anything will work. I think it's quite true. Anything will work. Okay. Right. Okay, that is actually number 4. For question 5. For question 5, what is the approach? For question 5, the approach is you might want to do this.
This question took me as content because
Huh?
I didn't think of just multiplying 5
Oh.
5 or 2. I didn't think of that.
You want to expand?
Yeah.
Right.
5 facts, I think.
Yeah, 5. Sorry, 5. Okay.
For A, for 5A. Huh? You can.
I don't think we can,
I don't suggest you to do so because
You shouldn't use squeeze theorem for number 5A, You did like Aiden. Squeeze theorem for 5A.
How do you do squeeze theorem?
Okay, let's have Aiden to present the board. Aiden, write neatly and bigly. Aiden has a different opinion. Can you write neatly? It's okay. Never mind, it's okay. Just write. Aiden will do 5A on the board neatly and bigly. 5B. You use the trigo identities. You just rewrite the Aiden says he wants to use squeeze theorem for part A. See he's working. For 5B, if you use the trigo identity, you're quite fast, I know. Quite fast. For part C, Kaiwen, you have something to say about 5C, is it? 有没有？没有。Brandon, 5C, how do you do it? Double hand formula, is it? Yeah. Did you think of using this? Okay. Right. This also will work, This also will. Okay. That brings us to number 6. Okay, I intend to wait for Aiden so they can join us on number 6. Okay. Let's be examiner.
Okay, you got the right concept. You made it a lot easier.
I know it made it a lot easier.
Yes, but I think it's okay.
Yeah, it's correct.
I think it's okay.
Yeah, it could be a lot
I do not see immediately any flaws. Yeah. You just took the definition of how you got sine x over x and just expanded back. Yeah.
If you produce a solution like this, right? This first line.
You have to draw the triangle.
Yeah, you have to provide a bit of
Context.
yeah. You have to provide a bit of reasoning. right?
But you can't just.
It's a nice solution, you know. It's a nice solution. Just that the first line becomes questionable. You know what I mean? You can just say refer to page whatever from the notes.
Yeah.
You win.
If you can remember the page number, that's
Write it in the exam.
a lot of times in the exam I was like thinking, can I just say refer to example one point something, and then it's like, okay, the proof is there. I'm not gonna prove it. The proof is there.
Okay. Anyway, Aiden, the 5A right is only 1 mark.
Yeah.
Okay, but good solution that you produced.
It's a healthy solution.
For number 6, part 1, class, I prefer that you do not write down the answer right away. I prefer that you write down this as limit x goes towards 2 minus. I want you to write down 8x first, and this becomes 16. And then likewise for the other one, right, becomes limit x goes towards 2 plus. 2 plus, right, you use ax square, so that gives you 4a. For part 3, right, if you straight away say like that, class, I want you to know, you straight away say the answer is 4, you get 0. I want you to know, you get 0. What you need to do is, you gotta say from this line, right, from this one, it therefore implies that you have to say, you have to say explicitly. There are a lot of writing to do, I agree, and you just don't like it, but you want to know, this is what you look out for in your presentation, missing which, you get 0. Okay? We are very particular about how you present your solution rather than just giving the answer. So please write adequately. Okay, now to check whether or not it is continuous at x equals 2, you now have to work out the limit on both sides. The limit x goes towards 2 minus of fx, right? We have found it earlier, right?
You can do that?
We have it 16, right? 16, right?
Yeah.
And then
Do you know where limit fx exists? So you know that it's 16, then the fx to 2 is just 16, only in no direction.
okay, what am I doing? 8 first. Okay, so the limit is 16, right? Okay, let me redo. Okay, you know this result. 1,
No, f2 is 16.
and then
F2
2,
is 8
2, right? 2, f of 2
is 16.
is equals to
8 times 2,
8 times 2.
which is 16.
So number 3,
Number 3,
f of 2 is equals to the limiting value.
x to 2 fx. So we have all 3 conditions, that means it's continuous.
So from here, right? Therefore, by 1, 2, and 3, f is continuous at x equals to 2. Okay, let me do this first, okay? Let me disconnect first. Disconnecting the network will be helpful for me, because things won't go wrong. Okay, so that's actually the part 4. So when checking whether or not a function is continuous at a certain point, you really have to do the hard work, You really have to go through the hard work of doing that thinking, You know what I mean? Show the 1, 2, and 3, and then conclude based on the 1, 2, and 3. And now we are into part 5.
So the derivative does not exist.
Okay, part 5, right? part 5 is now covered up by the part 4 working. I need to do some erasing. Okay, I'm going to erase all this portion here. Okay, if you look carefully at part 5, class, this limit that you're asked to find, actually it is the same as finding f prime of 2. No? Finding the derivative at x equals to 2. Now, to find this limit right now, because the function is defined differently on either side of 2, to do this question part 5, right, you really have to go through that trouble to actually work up this, And also to work up this one, Okay, considering that a lot of people haven't done this one, I like to suggest that you spend that 30 seconds or so to finish up this one, because it's important for you to know how to do this kind of question, Okay, so for the first one, it becomes limit x goes towards 2 minus 8x. X minus 2, 8. Okay. And then this other one, for 2 plus, right? Okay. I think it's 16, is it? Check for me, is it 16? Because A is...
Huh? Oh. So you can have 5, question 6.
Can I make a mistake? Okay, it looks funny. Wait, give me a moment. 8x squared. Ax squared. No, I wrote only. Should be writing as...
For the positive side is 16 one. Yeah.
Right. I wrote wrong just now. 4x squared. Okay, like that. Okay, and this is not equals to limit not 0, not 0. Therefore, limit does not exist. So this is how you ought to do the part 5.
Okay, these are the easy questions.
Right. So like what Kenneth said, these are the manageable questions.
Suppose.
Okay. For number 7, right? For number 7, okay, let's pause a moment. Number 6, part 5. Okay, all okay. For number 7, who has done number 7, part 1? Kenneth. Okay, good. Let's have Theophilus. 7, part 1. Right, Bickley and Nixley.
This was actually one of the questions I was struggling for quite like.
Oh,
because of
okay.
Me trying to be a lot more fancy.
Now I can transcribe this into
Yeah, neat version, of 7 part 1. The rest of you haven't tried, no? You want to give yourself a chance to try 7 part 1. It's worth the while.
I just say question 10, I have no idea how to write.
Number 10.
Question 10.
What's question 10?
Square root x times 4 minus x.
This question.
I have no idea what the because it just feels like the limit. You can just substitute the number in and it's still correct. So it doesn't show anything. I feel like it doesn't show anything.
No, because square root is a continuous function. This is a continuous function. This composition is also a continuous function. Finish. X into 4 minus x is continuous. This is polynomial.
Nah.
Square root is also continuous.
Continuous, yeah.
A composite function
Composite?
where the two functions are continuous.
Continuous is continuous.
Yeah.
Yeah, so basically that's it.
Yeah, just say it only.
Yeah, so I'm trying, I looking at the hint here, like, what is it trying to say to me?
It's like too simple. Right now.
Yeah. Yeah, just skip question 10 for now.
I think you should skip number 10, right?
I didn't, I just stopped at 9.
Okay.
But I've completed the back questions already, so I just continue doing on this paper. Yeah.
Right.
There's also question 14. B is a hard one.
Okay.
Wait. Like,
For those who haven't tried 7, you want to try, give yourself a chance. Hey, Theophilus is left-handed.
Yes, I am.
Okay. We are friends. Why don't you write beneath it instead of squeezing it there? Because the screen will actually block our view. Curtin, you finished all already, right? 14, have you done?
wait, what?
He says finished all already. I'm just asking whether he's done 14.
Yo, you finished the last, you finished 14B, ah?
No, I've not made problems.
Yeah.
I think I'm done. Oh. I'm being given a lesson why I should write me the first.
Okay, we are doing number 7 part 1, It's worth the while to do slower for number 7. Either you did 7 part 1 also, right? You found the value A first, right? Okay. 7 part 2? Okay. Okay. For those who are trying 7 part 2, right? You want to realize that the limit, right? The limit when x goes to 0 of this function, you got to understand something, no? This one, right? This one, will mean the numerator is 0, right? But to get 6, right? To get a 6, knowing that numerator is going to be 0, it only makes sense that the denominator must also be 0 when x goes towards 0. No? It has to be.
Must equals to x.
Otherwise, if the denominator is not going towards 0, right? Then this whole thing will go to 0 straight away. No? It won't be 6. So there's something you want to note.
You get rid of the x.
Yeah.
You can also took me a bit of time.
What I'm trying to tell you is, from the fact that this is 6, right? This is 6, right? It tells you that this limit, as x goes towards 0 of this thinking, this thing has to be 0, which means root a minus b has to be 0. So that will help you. Okay, let me see it. Theophilus. Right. Yeah.
The brackets is very like inconsistent throughout the minutes.
That's square. Right. Good. In case you're lost where you got this one from, this one is actually from here. He jumped. The two jumps. Then Theophilus has two jumps. The flow is a bit distorted. So this patch here actually links up with the one on top, and this patch here links up with the one below. So what Theophilus did was, he used the given condition to find the value A first. Let me say from here, he managed to show that, from this sentence, that he managed to show that A equals 6. Sorry, not whole thing 6. That A is equals to 6. Okay. Then he managed to reduce this into limit x tends towards A of.
Isn't it supposed to be plus?
Yeah, it's supposed to be plus.
No, isn't that supposed to be plus?
That's very plus. Yeah. That this equals to x squared plus A squared. So from here to here, right, he uses just purely factorization, you know. So by finding the value of A from the first limit, coupled by the use of factorization on the second limit, he managed to conclude that the required answer is this 72, is it? Oh, 72, yeah. Good. For those who haven't tried SEM Part 2, with the short discussion I've given you there about this, hope that it helps you to bring yourself through SEM Part 2.
Some actually is nice.
Part 3 is nice, is it? Okay.
You have to recall what we learned last year.
Okay, so I guess Kenneth, invite on this side and do your SEM Part 3 here.
Yay!
Right, Nixley and Big Lee on. I want to stress this thing, no? You must write Nixley and Big Lee. Because I sometimes cannot see neat but small handwriting, you know. I have a lot of problem. You stick in. Where were you just now? Harohi, is it? Harohi. What are you doing?
I had an appointment.
With?
For like passport stuff.
For passports.
Yes.
You went to ICA,
Yes.
Okay. I thought this passport is like you apply and then just find a day and time to go and collect it.
I'm not sure.
Okay. Your parents came and fetch you and we went together to get the passport. So good, yeah. Okay, so we can travel later. Where to go to? Where are you traveling to?
I just have it. I don't like. I'm not traveling anywhere.
But you know that when you get a passport, right, the 10 years or 5 years thing start from the day you collect passport. So you're not traveling for the next 1 year, the 1 year is wasted. You know, the passport only lasts for 5 years or 10 years. 10 years now, is it? Last time I was very lucky. Last time actually, you travel to Malaysia, right? There's a separate passport, you know. It's called a West Malaysia passport. You have 2 passports last time, long ago. I traveled to Malaysia quite a bit, like, you know. I quite go there. Big country, nice. I'm not Malaysian, but the country is big. It's good to drive around, eat there, you know. Okay, part 2. Who has? Well, he's doing part 3. Someone is doing part 2. That has to be Tyler, right? Tyler can do part 2, right? Part 2. 要不要? Okay, not okay. Tyler's friend. Who's your friend?
Who is gonna
Can you nominate someone?
No.
Thanks.
I wanna drag someone down. I wanna drag
Okay.
tagging.
I can't remember your name. No.
Tagging.
啊？建分 ，OK， 建分。7 part 2 you done or not？ 没有 ，OK。I know someone won't fear me, and that is Curtin. 7 part 2. On the spot and just finish it, 7 part 2, Curtin. Any SMTs today? Oh, okay. So I'm going to erase this thing. I'm going to do whatever I can for 7 part 1 and 2. For 7 part 1, right? If you were to, it's on the board just now. Yeah, yes, it is down on the board. Sorry, I'm silly. Okay, in that case, I must actually take a picture of the 7 part 1 and put the class WhatsApp.
Yeah, that's what's that.
You do, right?
Yeah, I was not.
Okay. Let me see before. X 23544. Taiwan, is there something you can tell me? No. Class rep, who are the class rep? Have you all nominated a class rep?
No.
Who was the class rep last year? Who were the class rep? You and you Okay. Can you and you do up the sitting plan here so I can call people by name?
Yeah, we haven't decided.
Like that lah. Okay lah.
Yeah, we are still deciding on sitting plan for now.
That's good. This sitting plan is good. So Kenneth is here.
With our Mr. Lim, I think he wants like group sitting or something.
Group sitting okay. Can you temporarily take over and then just do one plan first? Because Mr. Lim Chong, I'm not sure when we finish doing the sitting plan.
Mr. Lim.
Wen Kai. What's interesting is the thing fell from the table, right? And you pick it up, Then you put it back in the same location. So one day my daughter asked me, because something dropped off from my car when I jam brake, the handphone. Then my daughter said, "So daddy, why do you put it back in the same location?" Then I was puzzled for us. So I said, "Oh, so that it can drop again, I can pick it up again." So I think Taiwan is doing the same thing, so it can drop again and you pick it up again. Wen Kai. Okay, don't worry, I'll take over. Let me do 7 part 2 for you. Okay, class, let me do 7 part 2 for you, okay? Yep, let me do it for you. For 7 part 2, as I told you just now, this must be the case. This has to be the case. It has to be 0. So this therefore implies that root A minus B has to be 0. Oh, then because this is it involves a square, right? So we are going to do the same thing, I'm going to times by the conjugate. Oops. x plus a minus b squared. So when x goes towards 0,
If it's not 0, then the limit of the yeah. Imagine like 0 over 7.
do you realize that at this point, this fella and this fella, they can cancel off, you know. You know why I can cancel off or not? Because we have established that this is the case. So this means a minus b squared is 0. So you're left with x at the bottom and x at the top. So then this tells me, therefore, you have root a plus b is equals to 6. So let me call this one equation 2, while this is my equation 1. Right. So from here you can find your a and b. So from here, right, your b, by solving 1 and 2, right, by 1 and 2, your b is equals to 3 and a is equals to 9. Therefore, a plus b is equals to 12. That's how you do part 2. Okay, while you look at part 2, now let's look at the solution. There are 2 of them, you know. How?
Oh yeah. That's the same thing. In any case, it's the same thing.
Maybe.
I didn't know how to write this one.
Since the limit equals a over 2, which is independent of b. Therefore, b can be any real number. And then you resolve this one so that I can take a picture.
Benefit 7.2 is also there.
Hey, you did it, what?
I did it.
Oh, you did it? you.
Just casually send it back.
That's why I was puzzled. I thought you were all halfway back. I said, hey, where's the place? Okay, let me take a picture of this. So when you're not in class, right, you want to actually look into the class course, I know. It's either a video or photograph. Hoping that that will help to let you catch up in the comfort of home. And then anyway, if you're still stuck, you can always make an appointment, then we can meet up to see how we can resolve clarification. Yes, Mahil.
For 7 part 3, right?
Yeah.
Can we say that, can we factorize the inner part and then say that the thing is too small because it's going to infinity?
What? The terms are negligible. Like b is negligible.
Yeah, because like x is
Because when x very large and then it becomes simpler, is it?
yeah, can I do that?
Okay, so there is an opinion raised by Mahil. He says, if this goes to infinity, this b is actually negligible. You can just remove the b right from the start, and then you go through the same calculation and establish the same result. Technically, the idea is correct, no? But presentation-wise, people don't do that, no?
It's hard to
It's a
understand.
clever observation. Yeah. Okay. Alright, that resolved number 7, you know. Any question to raise about SEM part 2 and part 3? Okay, you don't have. Let's press on with number 8. Okay, number 8 wants you to evaluate the limit when x goes towards 0. For finding this limit, right? For finding this limit, again you use the same trick that I showed earlier on. You write this thing as 2 limit x goes towards 0. That class is a fun class. I'm sure you want to be in that class. No,
Debatable.
quite nice, right? A lot of happenings.
Plus it's a quiet one.
My daughter told me many times she likes to be friends who are very noisy. I was wondering, no, is she also noisy, you know? Yeah. So I think next class you have a lot of people who are very high, you know, so it should be very fun.
The good thing about noisy friends is that they can talk for you.
Yeah, maybe you're right, no? That's why my daughter say, so that there won't be any moment of silence, you know, nothing to talk, she told me. Yeah, maybe you're right. Caitlin just,
503 became the drugstore.
yeah. You have energetic friend, they just do all the talking, you just listen to do.
Yeah,
503 just
Yeah.
503 just became the drugstore. Everyone is very high.
Okay, for this question part 2, again we stress on presentation, no? If you immediately right now answer, you're doomed, you know. You can say because it is continuous, so the limit implies 2 is equals to b, or I think better that way wrong. B is equals to. Okay. Then the part 3, right? Part 3 is good. It says use the calculator. So this gives you sine of 2x. This is 2, right? So do you use a calculator? Using the value of b. B is 2. Do you know where to find this key on the calculator?
Yeah.
You need to use the GDC, you know. Alright.
Which chapter? Okay, there are more additional practices.
Supposedly, if you don't use a calculator,
It's not that hard. So.
if you don't have a calculator and you still want to do it right, I would recommend that you do this, no.
Yeah, what's that? What's that? Every time when I try to like look up answers or something, try to look up like working, I always use the what?
L'Hopital's. Okay, just to show you this rule in action, okay?
Or Bernardi.
First and foremost, you want to rewrite it as like that first. When x goes towards 0, what can you say about numerator? when x goes to 0, this is deemed to be the indeterminate form. Okay. When you have the indeterminate form, you can apply what is known as the L'Hopital's rule. How do you apply the L'Hopital's rule? No?
You derivative start with water.
You differentiate the numerator and then you differentiate the denominator. Right? And then again, again you find that when x goes to 0, you again have the indeterminate form, you know. You can then do it once more. Just differentiate, you know. And this therefore gives you 0. So, okay, let's do this as the last question, number 9, okay? Number 9. So we can have an early lunch. Number 9, it asks now, which of the following statement is or are true? Okay, first and foremost, is this true? Let's hear from Ke Yue, our class rep. Yes or no? Yes. Ke Yue, does this limit exist? Shh, quiet. Ke Yue is thinking hard. What is it equals to? I know, yes, but what is it equals to? Right, it's equals to 1. And this one also 1, you know, this is also 1. Okay, Ke Yue, part 3? Yes. Why is it yes? It's satisfying all the... Right, so therefore... Okay.